Okay, so this is going to be 3.5 where we're solving three variable equations. So my first step when I have these three variable equations is I want to look for the variable that will cancel very easily. So I need two equations that have the same variable that will cancel easily. So if I look this one and this one, my z's will cancel pretty easily. So I have 2x, this is my star equation, so 2x minus y plus z is equal to 4, and then 4x, oops, wrong one. My other one with the star is the x plus 3y minus z is equal to 11. So I always add going down. I got 3x plus 2y. My z's cancel. That was our goal. That's why we picked that one. Now I need to find two different equations that will cancel the same variable. Okay, so if I pick this one and this one, my z's will cancel easily again. So here's my square. So I have 2x minus y plus z is equal to 4. And 4x plus y minus z is equal to 14. So I was add going down, I got 6x. Our y's cancel, our z's cancel. We lucked out. That normally doesn't happen. 14 plus 4 is 18. To solve, we divide by 6. So I have x is equal to 3. I can plug it back into my two variable equation to find my second variable. So I have 3 times 3 plus 2y is equal to 15. 9 plus 2y is equal to 15, subtract 9, 2y is equal to 6, divide by 2, so I got y equal to 3. Now I need to find z, so I need to plug the two variables I have into my three variable equation. So let's say we pick this middle one here. I got my x plus 3 times my y minus z is equal to 11. So 3 plus 9 minus z is equal to 11. 12 minus z is equal to 11. Subtract 12. Negative z is equal to negative 1. Divide by negative 1. Z is equal to 1. So if we wrote it in alphabetical order, we would go x, y, and z. So the reason we have x, y, and z is because now we're not talking about a normal coordinate plane of just x, y. We're talking about a 3D plane that's going to have this z going straight through it. And we have three different lines. So we're trying to find it with the 3D plane this time. Okay, so our first goal is to find a variable that would be easily cancelable. So if we look at those, so I'm going to do my star equation here. So x minus y plus z is equal to negative 1. And my other star equation, x plus y plus 3z is equal to negative 3. When I add going down, x plus x is 2x. My y's canceled, which is why I picked it. So plus 4z is equal to negative 4. Now I need to pick two different equations that eliminate the same variable. The variable I eliminated was y, so I need to pick two equations that they would eliminate y. So if I pick this one and this one, it should eliminate my y. So x plus y plus 3z is equal to negative 3. 2x minus y plus 2z is equal to 0. When I add going down, I get 3x. My y's cancel. Plus 5z is equal to negative 3. Now I have two equations that are in terms of x and y. So I'm going to combine my two equations and eliminate those so that I can eliminate to get it down to one variable. So I'm using my star and my square. So I'm going to have 2x plus 4z is equal to negative 4. And then my other one, 3x plus 5z is equal to negative 3. So I need to pick if I want to eliminate my x's or my y's. I'm going to do my x's. So I'm going to multiply my top by 3 and my bottom by negative 2. 3 times 2x is 6x. 3 times 4z is 12z. And 3 times negative 4 is negative 12. Negative 2 times 3x is negative 6x. Negative 2 times 5 is negative 10z. Negative 2 times negative 6 is 6. I add going down because we're doing elimination again. So you do elimination 3 different times. My x's cancel. 12z plus negative 10z is 2z. Negative 12 plus 6 is negative 6. I divide both by 2 and we get negative 3. So I got 1. Now I have to plug it into a two-variable equation to find the second variable. So I'm going to look at my two-variable equations. We can plug it into this one. So I have 3x plus 5 times negative 3 is equal to negative 3. So 3x minus 15 is equal to negative 3. Add 15. 3x is equal to 12. Divide by 3. X is equal to 4. So now I have 2. I still need to find y, so now I need to go back to my top equation. Let's say we plug it into my top one here. My x was 4. I don't know my y, so I'm going to put minus y. And my z was negative 3, so we're going to put negative 3. We got to solve for y, so 4 minus 3 is 1. Subtract 1, I get negative y is equal to negative 2. Divide by negative 1, so y is equal to 2. So you do elimination 3 times, plug it back into your 2 variable, then plug those 2 into your 3 variable. So this point is going to be 4, 2, negative 3. All right, our next one. So we want to find one that we can eliminate pretty easily. It looks like my x's here could eliminate easily, so let's star those and do our star equation here. So x plus y plus 2z equals 3. Negative x minus 2y plus z is equal to 10. Add going down, my x's cancel. Y plus negative 2y is negative y. 2z plus z is 3z and 13. So now I need to pick 2 different equations that will eliminate my x's easily. I don't have 2 that are going to eliminate x really easy, so we're just going to pick this one and this one because one's positive and one's negative. So I'm going to do my square equations right here. So 2x plus y plus 3z equals 7, and negative x minus 2y plus z is equal to 10. So to get my x's to be the same, because I'm trying to eliminate x's, I'm going to multiply my bottom by 2. So I'm going to get negative 2x minus 2y plus 2z is equal to 20. I'm going to drop my untouched equation underneath it. So 2x plus y plus 3z is equal to 7. My x's cancel. This becomes negative y plus 5z is equal to 27. So I can take my 2 equations, since they're both in terms of y and z. So my star square equations, and put them on top of each other. If I want to eliminate my y's, I need one positive, one negative, so we're going to multiply this one by negative 1. So it becomes y minus 3z is equal to negative 13. I'm going to drop my untouched equation right underneath it. So my y's cancel. This becomes positive 2z. And 14, so when I divide by 2, I got z is equal to 7. I always plug that into my 2 variable equation, so let's just plug it into our square here. So negative y plus 5 times 7 is equal to 27. Because we want to be able to solve for one of our other variables. 7 times 5 is 35. Subtract 35. So I get negative y is equal to negative 8. Divide by negative 1. So I have y is equal to 8. Now we take our 2 and plug it into one of our 3 equations. So I'm going to plug it into that top one, that x plus y plus 2z is equal to 3. gosh, it's equal to 3. I'm going to replace my z with 7 and my y with 8. So I have x plus 8 plus 2 times my z is 7, x plus 8 plus 14 is equal to 3. 8 plus 14 is 22. Subtract 22. So x is equal to negative 19. So when we write it x, y, z, I got negative 19, 8, and 7. Negative 19, it lets me write it, 8 and 7. All right, this one we're missing a variable. So since we're already eliminating our z in this, I'm going to take these two equations and eliminate the z, because it's one less elimination that we're going to have to do. So here is my star, if it lets me write it. So 2x plus 3y minus 2z is equal to negative 1. Negative 5x, plus 4z is equal to 4. Come on. Okay, so right now I want to eliminate my z. So I'm going to multiply this top by 2. So when I distribute, I get 4x plus 6y minus 2z is equal to negative 2. I'm going to put my untouched equation underneath it. There's no y in it. Oops, that was a minus 4z, because this is a plus 4z. That's why we multiplied by 2. It's equal to 4. So I always add going down. 4x plus negative 5x is negative 1x. We bring our 6y down. My z's cancel. 4 plus negative 2 is 2. So now I have my two equations that I can put on top of each other that are both in terms of x and y. So I have this equation here and my equation I just found, so we can eliminate based on that. So I'm going to put that x plus 5y equals 9 underneath this. X plus 5y is equal to 9. So my x's will eliminate automatically if I add down. So I get 11y is equal to 11. Divide by 11. Y is equal to 1. We have to plug it into a two-variable equation to be able to solve for a second variable. So if I plug that into my x plus 5, y is equal to 9. I get x plus 5 times 1 is equal to 9. X plus 5 is equal to 9. Subtract 5. So now I have x is equal to 4. I take those two and plug it into a 3-variable, or what I could do is plug it into this and just plug my x in and solve for z. So if I do that, my x was 4. So I got negative 5 times 4 plus 4z is equal to 4. Negative 20 plus 4z is equal to 4. Add 20. 4z is equal to 24. Divide by 4. So z is equal to 6. So now I have my x, y, z. It is 4, 1, 6. All right, our next one, we're missing a this time, so let's get these and get rid of the a. So I have a plus b plus c is equal to negative 3. 2a minus b minus 2c is equal to negative 5. So let's multiply this top by negative 2. This is my star equation. So I get negative 2a minus 2b minus 2c is equal to 6 when I distribute that. I'm going to put my untouched equation underneath it. So 2a minus b minus 2c is equal to negative 5. that when I add down is negative 3b minus 4c is equal to 1. I'm going to bring that other equation down below it because they're both in the same terms now. So 3b minus c equals 4. So 3b minus c is equal to 4. My b's automatically eliminate right now when I add down. So I get negative 5c is equal to 5. Divide by negative 5. C is equal to negative 1. I have to plug that into a two-variable equation. So here is my two-variable equation I'm going to plug it into. So c right now is negative 1. So I get 3b minus, oh my gosh, plug in a negative 1 if it lets me write it. Come on. Is equal to 4. So 3b plus 1 is equal to 4. Subtract 1. 3b is equal to 3. Divide by 3. So I got b is equal to 1. I need to plug those into one of the three variable equations. So my a plus b plus c is going to be pretty easy because I'll get a plus my b, which is 1, plus my c, which is negative 1, and it equals negative 3. 1 plus negative 1 cancels. So a equals negative 3. So my answer is A, B, C. Make sure when you're doing these problems that you line up your variables, so x on top x, y on top y, c on top c. You might leave a space if they don't have one, and then make sure all of your variables are on the same side of the equation, so kind of in standard form, x and y and z all on the same side of the equal sign.